Hey everyone, so like I said, I was going to make a video on how to solve part B of problem 3 in the design challenge. So it's pretty straightforward. If you don't understand the concepts like behind it, I'm kind of going to go over that as well. But in Excel, it's pretty straightforward. And I know the video is like kind of late, but I only saw 5 people out of our like 30-ish people submit it. So I don't know, maybe you guys are like still working on it, or yeah, if you didn't want to do it over spring break, I don't know, I kind of don't blame you. But yeah, I'm gonna go ahead and get into like what's going on behind it and then how to actually solve it in Excel. So we're given this system of equations here, and a system of equations in this form means usually that there exists a solution where these x's are the same, these y's are the same, and these z's are the same for these coefficients right here, like this 2, -3, 1, 5, 1, 1, 1, 5. There's solutions that exist for those x, y, z values that give us these answers respectively for each equation. So getting into like more of what that means, I kind of have like this little example here. So if I have two lines and they're represented by these equations here, you can see they intersect, obviously. So they intersect here. Bam, right there. It's pretty obvious, but they intersect there. So what we want to do, this is a two-dimensional case, keep that in mind. So we wouldn't have z in this case. And we probably wouldn't need a third equation. So what we have here is pretty much just two lines that intersect at this point, and we want to find what this value is for x at which they intersect, and we want to find the same thing for y. And that's basically it. So in order to do that with matrices, we need to write these equations in something known as standard form, or I believe it's standard form. So this equation in standard form is simply 3x minus y is equal to 20. And this one in standard form is 0.5x minus y is equal to -3. So when you go ahead and you write this out, when you have these equations and you have them in a matrix kind of form, you'll end up with something like this. Not that one. So my coefficients here, 3 and -1, will go here in my matrix, and my answer for this here, which is 20, will go here. And these will produce like this will produce a 2 by 2 and a 2 by 1. So and just respectively, so 0.5 here and -1 here and -3 here. So when we're trying to find what this x and y values are going to be, which is, like I said, this x and this y, when we're trying to find out what those are going to be, in Excel we use this thing called the inverse of a matrix. So it's simply, when you start writing it out in Excel, the inverse will be the same size as the matrix that you're trying to get the inverse of. So I'm going to highlight four cells here. I'm going to start typing my equation. So to get the inverse of a matrix, it's M inverse or minverse, who knows. And you will select your array or your matrix, close the parentheses, and remember to hit Control-Shift-Enter, and then you get an inverse. So this is pretty much known as to -1. And that's what that equals. So once you have the inverse, this is why Excel is so great, because instead of having to like do other steps in algebra that are, well, not unnecessary, but that are lengthy compared to this, Excel does it in, you know, in a click of a button of enter. And the next step would be to multiply this inverse by what I'm calling this column, or this matrix, B. So I'm going to go ahead and do mmult in Excel. My first array or matrix will be, I'm sorry, not that one, this one here, your inverse. And then your second array would be this one here. And I didn't select multiple cells, but it's going to be, for this particular example, it's going to be 2 cells that will be affected. So I'm going to hit Control Shift Enter, and I don't know if this is going to work properly. Let me see. And no, it didn't. I'm just going to go ahead and select two cells, do it over. And Control Shift Enter. And there we go. So this is my solution. So this number, this first number at the very top, is going to be my x value. And this number at the bottom is going to be my y value. So what that means is that this y is going to be equal to 7.6. And this x is going to be equal to 9.2. And I think at this point you probably get it. I mean, you probably understand. So the same thing goes for trying to find a similar, or trying to find a solution for a 3-dimensional case, which is what we have in our problem here, because we have z. So we just pretty much have something that's like and so this becomes like a 3D kind of thing, and then there's another line that maybe comes here, and they all intersect at this point. So we now need to know what this z value is, so at which it intersects. But this is assuming that like this isn't the equation, because now there's like a z involved. So it's pretty much the same concept. So I didn't use the actual numbers because I think, I don't know, you should probably use them on your own. So I'm just going to go ahead and, well, let me select my cells. I honestly think it's easier that way. Select my matrix, Control Shift Enter. Okay, I guess I somehow took a screenshot. Control Shift Enter. And I have my inverse, and now for my solution, I'm going to select 3 cells, mmult, my inverse matrix, and then comma, my B matrix, and Control Shift Enter. And these are my solutions, so x, y, and z. So this is as if I had, this 4, 2, and 4 were right here in front of, like this 4 was in front of this x, and this 2 was in front of this y, and so forth. So the solution, the numbers that satisfy are these here. So computing the 3 unknowns is pretty much, is in itself solving the solution to this system of linear equations. And that's pretty much it. So thanks for watching. I'll see you tomorrow, I guess, if you're watching this video today, which is Monday. But yeah, I will see you guys soon. So take care.